we expect more than, so we do not expect one solution. Remember the formula, number of variable minus number of equation is equal to degree of freedom. Number equation of 4 in our example. Number of variable 4, sorry. Number equation is 3. We have 1 degree of freedom. That means that we have at least no, in this case we have only one free variable. Therefore, we have infinity many solutions, no? So we expect that. Okay, so now, do you want, I do for you again, the reducer row echelon in GeoGebra, or you practice by yourself and you are strong in that part? Answer me. My question was, do you want I go to GeoGebra, type in the number, solving, or you have no problem with that part? Because
you should show us how to. I think you should go over the GeoGebra part.
Okay, no problem. Okay. Do you see?
Yeah, we see.
Okay. Now remember, we go to the view and you select graphic, CAS, and spreadsheet. Boom. In spreadsheet, you type in, this is working as a matrix editor. Fine. And 1, 0, off, 0, and 1. Okay. The second equation is 2, -1, 1, -1, and 3. Okay. And the third equation is 0, 0, 1, 1, 7. Okay, that was in the spreadsheet. You select, you create the matrix. There you go. I have here in algebra our matrix. Now in CAS, you could reduce a row. No. Capital. Reduce a row. Reduce. Yeah. And the matrix N1. Enter, and this is the answer. Okay. Don't worry for the answer. I copy in the whiteboard now. He analyze the solution. Okay. You practice that part or no? Everyone practice that part? This is important for this test. Because do it by hand, this is crazy. The idea is not this. The idea is using software. And interpretation is the most important. Okay. I come back. Whiteboard. You see whiteboard? The whiteboard?
Yeah, we see it.
Yes.
Okay. Look, we have 1, 0, 0, -2/7, -3/7, 0, 1, 0, 10/7, 22/7, 0, 0, 1, 1, answer. Okay, interpretation this answer. I know, okay, my system is underdetermined. Degree of freedom is equal 1. Now we have free variable. How do you determine free variable? I can see clear like water. This is the identity matrix. identity matrix, dimension 3, because it's 3 by 3. And the extra column is a free variable. This is obvious. Okay. X, Y, and Z not free, and W free. Okay, and you're right. Each row has equation. You see, we have 1x minus 2 over 7 W equal negative 3 over 7, que is equivalent to, say, x alone. You isolate always the non-free variable, negative 3 over 7 plus 2 over 7 W. Y similar. Y plus 10 over 7 W is equal to 22 over 7. Y is then 22 over 7 minus 10 over 7 W. And Z, C plus something, C plus 1 equals 7. Therefore, C is equal 7 minus, pero es W, sorry. This is W, minus W. Okay, so the solution is the object living in the 4-dimensional space, because we have 4 variables. Solution set is x, y, z, w, such that you copy this expression, this, and this. I don't want to copy again. You copy this inside here, and you declare that W is any real number. And that's it. The solution is the line, but of line in 4-dimensional space. So the solution object represents a line, but in 4-dimensional space. It's impossible to represent geometrically. No. I suppose the answer is 8. It's 8, yeah. It's 8. Any question, guys? Do you understand very well this one? Yes, no? Answer me.
Yep.
Okay.
Yes.
Okay, no problem. Let's move on to the next question, next page. It's about determinant. It's easy, super easy determinant. Determinant now. This one. Okay, I want to do this by hand, but you know it's possible checking in GeoGebra, no? Suppose number 12, case 1, 1, negative 2, negative 2, 4, negative 1, negative 3, 5, 5. Determinant is different to the matrix, because determinant compute one number que represent determinant. It's a function. Entonces now, what's the formula? Well, the cofactor formula. In this case, I expand using the row 1. Row 1 is this. Row 1. Yeah, I copy 1 by 1 the coefficients. 1 multiplication by cofactor, and cofactor is determinant gets formed by, we delete the row 1 and column 1. Entonces es 4, negative 1, 5, 5. Do you see how I get the cofactor? You delete, in that case, row 1 and column 1. And this is that number. And the cofactor have a sign. So when you navigate for the second number, I did that. The second is negative 1, because the cofactor is negative in this case. Negative 1 time, and likewise, you delete the row 1 and column 2. Negative 2, negative 1, negative 3, and 5. Plus, the last cofactor is negative. Actually, it's negative. So no plus is negative, because the number is negative 2. No? The sign default of the cofactor is positive. However, the coefficient is negative, and positive and negative together, it's obvious que es negative, ¿no? Entonces, negative 2 Entonces we have -2, 4, -3, and 5. Okay, the minor when you delete the row 1 and column 3, this guy. Makes sense so far? Makes sense so far or no?
Yes.
Now, the rest is easy. The rest is one invisible multiplication. You multiply like that. And this multiplication, you don't change the sign. And this, yes, you change the sign. You introduce one artificially, -1. So actually, it's 20 plus 5. Because 5 times -1 is -5. Another negative you introduce in the algorithm is negative. Now here is a -10, -3, because you have 3 negative in that case. 3 negative is negative, and this is negative also. The sign actually is positive, but it's -2 times 5 is -10. -2 times, this and this is -10 again, plus 12. Because -3 and +4 and extra negative become positive. This is 25. This is 13, -13, but minus plus 13. And this is minus, this is 2 times 2 is 4. And the answer is 25 plus 9 is 34. 34, 34, 34, positive 34 is B. Everyone understand that? Everyone understand that?
Yeah.
Yes.
And you know how you check it in the GeoGebra or no? Do you want to show you or no? In GeoGebra.
Yes, please.
If you can,
Yes,
please.
please. Yes, please.
Yes.
Okay. Okay, I typing in the spreadsheet the number, no? 1, 1, 2. 1, 1, -2. Actually, determinant is only possible doing by square matrix. 3 by 3, 4 by 4, 2 by 2. No rectangular. 4, -1. It's important that you make sure you type in the number correct and the corresponding sign. So you change something, is another problem, and the answer is different, completely different. Okay, so now you select this, create matrix. Actually, no matrix determinant, but you navigate for the matrix first. And in caps, you put determinant. Determinant. Look, determinant of the matrix N1. Center, boom, 34. You see? Super clear?
Here, sir.
Yes.
Super clear. Okay, let's move on to the whiteboard again. Because I don't want to repeat again what GeoGebra, no? You know, this is mechanical.
Good afternoon, Professor.
Hey, hello. Who are you?
This is Nermin Bader. I'm sorry for joining late.
No, it's okay. You are good students. You never are doing that. Okay, entonces come back to the whiteboard. Do you see whiteboard?
Yes.
Yes. Yeah, we do.
Okay. Let's do number 13. Number 13 is easy. Why is easy? Because the determinant have a lot of zero. So when you travel for the row 1, remember you can expand using any row and any column. Any row or any column, and the answer doesn't change. I guarantee you 100%. Well, in this case, 3 times something, times 6498, and you multiply here at 48, it's 3 times 48 minus something, minus 36, this is 12, 3 times 12 is 36. Boom. Final answer. So you take advantage in the real life, you select the row or the column that contain more zero in order to simplify the computation of the determinant. And bueno, see, we have no. Okay. 14 is super easy. Why? Because you can see. Okay, we have. Look. We have in that determinant 1, 2, 3, 255, 1, 2, 3. Now I know a property. Okay, when the one determinant is 2 row or 2 column are equal, in this case I see that row 1 is equal to row 3. Do you see? Identical. Look, this row and this row is the same. When the situation happens, the value for this determinant is 0. Not always when it's equal, it's not proportional. Suppose another example is 1, 2, 3, 255, and this is 246. It's also 0 because it's proportional. Okay? You can verify in Georgia if you want. Okay? Let's move on to the Kramer rule, 1516. Everyone follow me, yes or no?
Yes.
Yes.
Okay. Kramer rule is another algorithm to solving system of equations using determinant in that case. So say you have, for example, 5x plus 9z equal 52. This is my first equation. Minus 6x plus 3y minus 8z equal negative 42, my second equation, and 2x minus 6y equal negative 14, my third equation. So my system, I need to find the solution using Kramer rule. Okay, the organization is clear. Look, you compute first of all capital D. Capital D is determinant 3 by 3, of course, because we have 3 variables formed by coefficients in front of the variable. 5, 0, 9, negative 6, 3, negative 8, 2, negative 6, 0. Okay, when the one variable is missing, you put 0, no? Now, you compute 3 more things. You compute dx, you compute dy, and this is it. It's only mechanical, replace the original determinant that was formed by coefficient C in front of the variable by the right-hand side number and the corresponding column. This is the column of the x, this is the column for the y, this is the column for the z. So 52, dx is you replace the column of the x by the right-hand side number, negative 42 and negative 14. And the rest stay the same, 0, 9, 3, negative 8, negative 6, 0. Now let's do exactly the same action, but on the column of the y. Now this column stays the same. Now the y column now is 52, negative 42, and negative 14. And this z is, 5, negative 6, 2, 0, 3, negative 6, and the column for the z is now replaced by 52, negative 42, and negative 14. Do you understand very well this organization? Kramer rule, Kramer rule. Some people lie. Actually, I don't lie, but it's okay. It's another way. And you can compute this in GeoGebra, for example, because it's too long process by hand. Before I give you the answer, the answer is 30 here. The answer is 150 here. The answer here is 120. And the answer here is 90. Okay, entonces the crime is say x is equal division dx divided by d. Y is division dy divided by d. And c is dz divided by d. And the first is 150 divided by 30 is 5. And the second is 120 divided by 30 is 4. And the last one is 90 divided by 30 is 3. And the answer is the triple order 5, 4, 3. End story. Option A. Let me show you. 5, 4, 3. This one. Super clear? I know it's too long. This is not the point. It's easy, the organization, and each determinant you can put it in GeoGebra and compute that. Any question? Do you want to do in GeoGebra or no?
It'd be nice, actually.
Okay, no, let's do it. Yeah. I obey your commands. You say do it for me, I do it for you. Okay, let's do it. Okay. Actually, for me, the most complicated part is not doing. You know, it's switching the window. Do you see that?
We see it.
Let me delete this information. Okay, I type in D. Who is D? DFI. Zero. 9. Negative 6. 3. And negative 8. 2. Negative 6. 0. Do you see I doing slow down because I make a mistake in one number, screw up everything. Well, I select the matrix, boom, I rename the matrix, look, I right click on the object, and I rename, this is D, no M1, capital D. Ready, y en cast, I compute determinant. Determinant who? Determinant D, capital D. And the answer is 30. Do you see? Okay, the rest is easy because here I organize in that way. I copy here 52. Copy here negative 42. I copy here negative 14. It's the right hand side number. Good. So I select my matrix, the original. I copy, I paste. Paste, paste, and paste. Okay, here I copy the right hand side. Copy, here I replay here. Come, replay here. Replay here. Do you see the action that I'm doing?
Yes.
And create two more matrix and compute the determinant. create matrix. This is the x, no? dx. Okay, I compute the determinant for dx. Determinant for dx. Dx is 150. Do you understand very well or no? I continue or no?
No, I understand now.
Ah, clear. You have to practice, guys. You have to practice, okay? Okay, it's interesting doing one more example because I have surprise in the next example. The next example bring me surprise. Okay, here you go. Okay, boom. Next example is, look. Suppose I want to find directory D. Well, D is 1 negative 1 4 2 0 1 negative 1 1 negative 4. Let me check in just in case. 1 negative 1 4 2 0. No y in the second equation. 1 z negative 1 1 4 negative 4. When you put in algebra or you by hand this, the answer is 0. Wow. And you know the rule of the Kramer is say that x is equal to dx divided by d. And you know when the d is 0 and the denominator is undefined. That is the reason that we cannot apply the Kramer rule. It's a disadvantage of Kramer rule. When this situation happens, it's because the solution is not unique. Or you have infinity many solutions, or you have no solution. Pero es, ambiguous. You don't know exactly what's going on. Therefore, this is disadvantage of the Kramer. Okay, let's do it now. Property of determinant. Manipulation for the property. 1718. Okay. In your moment, I explain several properties for the determinant. You apply, in this case, you can apply row operations, column operations. It's given, for example, this determinant is given as x, y, z, UBW, 1, negative 3, and negative 1 is given, is equal 38. I need to compute one that is similar somehow, que es x, y, UB, 1 and negative 3. You see that the column 1 and the column 2 is exactly the same. C minus x, W minus U, and negative 2. Compute that. This is the question. So I know the property can say that when you are doing column operation or row operations, the value of the determinant doesn't change. It stays the same. Unbelievable, but it's true. Entonces, what is the operation? Well, the operation que I use in my imagination. This is column 1, this is column 2, this is column 3. Suppose that I am doing column 1 plus column 3 and stores in the column 3. So basically, this operation I am doing in this column. In column 1, column 2, column 3. Entonces, when you add, this is the only column que change is column 3 because it's the result, is storage in column 3. Therefore, column 1 and 2 stay the same. So you adding this plus this. Es obvio que x is cancelled. And it stays z only. Likewise, happen in the second row. U is cancelled, XW. And -2 and +1 is -1. And this is exactly the same of the original case. I know that the answer is 38. So there are many ways to do this. One possibility is you apply the rule on the new determinant and going to convert like the original given, if this is a given. Or another possibility, this is the best way, because we have more degree of freedom. Okay, we have more degree of freedom to understand this. Do you follow me? Everyone understand this column operation? Column. Remember, in the matrix only we are doing row operation. In the determinant, no. It's more flexible. You are doing row operation and column operation. And it's perfect legal. I prove it in the lecture guide. And when the number, do you follow me? It's clear or confusing?
Clear.
Okay. In 18 question, it's a little bit more complicated. You have that determinant is given x, y, z, u, v, w, 1, -1, -3, and somebody say that the answer of this is 146. I need to compare one case family of this. It's a little bit more complicated case x plus 3, y minus 3, c minus 9, 3u minus 1, 3b plus 1, 3w plus 3, and 1, -1 and -3. And at least the last row is identical. So basically I need to manipulate row 2 or row 3. Let me see. Suppose que I'm doing this row operation. Row 2 plus row 3, storage and row 2. So you adding this guy plus this guy. And the result of this, I storage in the row 2. I did intentionally because I want to eliminate -1. So this -1, this -1 cancel out with the +1, -1 +1, -3 +3. Do you see the idea? Okay. Now I have a new determinant that is equivalent because when you perform row operation or column operation, the value of the determinant magically stays the same, doesn't change. And this is 3u, 3b, and 3w. And this stays the same. And the only row that change is the row 2. How do you know that? Because the only row in which you storage the information for the addition this and this together, plus storage and row 2. Sorry, 2. Okay. So far it's okay. So far it's clear or no? Or confusing? There are no recipe. This is you using your common sense, imagination. You need to know the property. Another property I use here is a common factor. You see that this 3, you factor out. It's possible. And you have UBW. Wow. I like this. Look like similar to the original. Okay, nice. Finally. I tried to modify a little bit row 1. To modify row 1, I propose you multiplication by -3, row 3 plus row 1 and storage in row 1 because it's the row I want to modify. Don't forget that 3 that you factor out in the last step. You multiply by -3. You multiply by -3. Look, I multiply by -3 by -3 by -3. -3 times 1 is -3, and -3 plus 3 is 0. And store this information here. Therefore, we have x alone. This is positive, minus negative positive y, and this is z, because 3 times 3 is negative 9. It's negative 9. It's negative 9. It's negative 9. It's negative 9, yeah. Wait. Yeah, negative 9. Something is wrong? No, it's negative 9, yeah. So it's UBW, and it's a 1, negative 1, and negative 2. Okay, this determinant is exactly the same of the original. Look at that. Okay, the answer is 146, and multiplication by 3 is 438. End of story. Do you see that or no? Oh, let me check it. Yeah. Yeah. There one. All right. Next page is the multiplication of matrices, que es super. Bueno, es long, pero using GeoGebra. I want to show you how. At least one example, and you can understand very well. Okay. Let's move into the next page. Okay, there you go. Okay, multiplication matrix now. Where is this? That one. Okay, little by little, you finish. Okay, suppose this. Suppose that the questions say multiply. Multiply who? Multiply that matrix. The matrix. It's a time. Multiplication. Okay, this is negative 3, 8, negative 6. Negative 3, 7, negative 2. Negative 2, negative 3, negative 2. Wow. Okay, the first thing you should do is verification of the dimension. This matrix is 2 by 3. Because we have 2 rows, row 1, row 2, and 3 columns. Column 1, column 2, column 3. This is 3 by 3, 3 rows, 3 columns. Entonces this must be matching. This number and this number must be matching always. If it doesn't match, entonces it's impossible. Like in this example, it's impossible. After it, you can see. Now the multiplication is too long, I know. But the most important is that the answer that we expect is a new determinant, the new matrix. Sorry, no determinant anymore. Okay, it's 2 by 3. Where come from this 2 and where come from this 3? This 2 is this 2, and this 3 is this 3. So we expect 6 numbers: 1, 2, 3, 4, 5, and 6. In this organization, it's obvious it's this answer, right? However, I want to show you anything in GeoGebra, of course. So GeoGebra is our friend to help me to avoid one heavy arithmetic in the matrix organization. Okay. Entonces I'm moving to GeoGebra. I need to delete everything. Delete. New GeoGebra. Of course, you can save the solution, no? But I don't want to save. Do you see? Do you see? Do you see or no?
We see.
Okay. Look. 3, 6. You check it, say make a mistake, let me know. Negative 8. Enter to change the line. Negative 9. Tab. 4. Tab. Negative 2. This is my first matrix. My second matrix is -3, A positive, -6, -3. Oh, -3 down, -3, 7, -2. -2 again, -3, wow, and -2. Okay, when I'm doing that, I am intention because I make a mistake one number, screw everything. So I select the first matrix, I create a matrix, boom, and 1. Okay, I select the second, I create the matrix, and 2. Now in cast, you multiply. It's important the order because n1 times n2 is not the same n2 times n1. The multiplication of the matrix is not commutative. But no, in this case, n1 time. Put the, how you put time? You put shift 8, get time after. But in the case, interpret the multiplication, n2. Boom! And the answer is -11, 80. -14, positive 19, -38, and 50. Exactly we predict at the beginning, according to analysis of the dimension. Super clear?
Clear.
Clear. Nice. So I propose you skip 20 and 21. 21, bueno, 21 is not defined because the dimension for the first matrix is 3 by 2, and the dimension of the second is 3 by 2 again, and doesn't matching this number and this number. It's impossible, the multiplication, and you see not defined. Got it? Sorry.
Yes.
You see one more? Sorry.
We still see zero algebra.
This is the most complicated for me. Because I focus on the mathematical part, I forgot to do this. Shui. Okay. Now, do you see? Do you see, right? Do you
No, we
see?
see it.
Okay. The thing I explained was, look, this is similar. I don't want to repeat this because it's the same thing. It's too long process, I know, but this is not the point. The point is, okay, it's easy, but it's long. And this is the beauty of that part of the matrix. So you understand that solving the system of equation by hand is crazy. Well, we can do that 3 by 3, 2 by 2, but yeah, 4 by 4 is a little bit consuming time. The mathematicians that create that tools and this algorithm to make easy the life. And you need to know, like engineer or scientific. Now in the 21, the thing I try to explain is the dimension for the first matrix 3 by 2, so 3 row, 2 column. And the second is exactly the same, 3 row, 2 column. And doesn't match in the dimension because the second number is the number of column and the first one must be equal the number of row in the second. No, so not defined. Any answer? Clear? Okay. Now let's move into the compute the inverse matrix. So we have one matrix given. Okay, is 4, 5, -1, and +1. And the equation say compute the inverse. Compute the inverse. The 2 by 2 is super easy by hand. 3 by 3, of course, horrible. But we can use in algebra. So now 2 by 2. 2 by 2 by hand. First of all, you determine the determinant. 4, -1, 5, 1. A multiplication. 4 times 1. And this. And affected by extra negative. Entonces es obvio que 4 plus 5 es 9. Okay, es 9. Now the thing is easy. You are doing this operation. You interchange this diagonal. So the inverse matrix, the formula is you interchange 4 and 1. 1 here and 4 here. Interchange this. Look, this is the action. And no change the sign. So the same sign but interchange. And the other no. The other you stay the same but you change the sign. It's -5 and +1. And divided by 9, que es the determinant. So it is the formula. The formula is, this is transpose something weird and divided by determinant. It's the formula. Well, when you divide one matrix by a number or multiply by scalar, is multiply or divide each element. So it's 1/9, 1/9, -5/9, and 4/9. End of story. This is the inverse method. This is the inverse of this. Verification, this just good. You multiply the original matrix times the inverse matrix in either order. Inverse matrix times I, and you expect to get the identity matrix. Look, that matrix. Let's do it, and at least one. Is suppose que by hand, this matrix is the original 4, 1, 5, 1, multiplication by 1/9, 1/9, -5/9, and 4/9. Okay. Okay. You multiply. How you multiply matrices? You multiply first row times first column. Okay, so you multiply is 4/9. You get, of course, you matching the dimension because look, this dimension is 2, this dimension is 2 by 2, this dimension is 2 by 2. They are perfect coincidence, 2 and 2, and you expect a new matrix is 2 by 2. This is always happen when it's a square matrix. Okay, so this is 4/9. Well, at least the first guy. I'll show you. The first guy is 4/9. This time this, and this time this is. Wait. Wait, let me see. Oof. I don't know what happened, bro. Let's do it in the GeoGebra to verify. After we check it. Okay, delete that. Easy. Suppose 4 -1. Do you see GeoGebra? Yes or no?
We do.
I see it.
And 1. Okay, this is the original problem. I create the matrix. And in cast you put invert. The notation is invert like that. No inverse it. invert matrix. Invert matrix is of the M1 is that number. Okay, it's the same number we get. Let me try to edit here. No. In case you can write, for example, invert again. Invert N1. Okay, N1. Multiplication by itself. Multiplication by itself, que es N1. The answer is identity matrix. Let me see how I confuse it in the. You multiply 4/9. Because I make a mistake here. Okay, it's negative, it's positive 5. No. It's because the original matrix is -1. Got it. Yeah. Do you see the process in GeoGebra? Let me finish in the whiteboard. You see one number screw up everything. Okay, my original matrix is no. It's -1. Look. Okay, switching again to the whiteboard. Okay, CC, however. Do you see whiteboard, right? Okay, I forgot. I don't know why. This is -1. This one is -1. I forgot. No, because you change the sign. Entonces es. Yeah. Okay. This guy is -1. Yeah, got it. This guy is -1. No, this is +1. This is okay. This is okay. This is not a mistake. The mistake is when I copy this guy, the original have a -1. Super. Entonces es, you multiply this times this. Y es obvio que es 4/9 plus. Because minus times minus positive 5/9. Que es 9/9. And 9/1 is 1. Right? Now, when you multiply now, this times this, it's obvious que es 0. Because 4/9 minus 4/9. Okay, when you multiply now, this times this, it's obvious que es 0 again. And when you multiply, that is 5/9. 5 times 1/9 plus 4/9, que is also 1. And you get the identity matrix. Do you see that or no? Do you see that? 1, 0, 0, 1. Identity matrix of dimension 2 because it's 2 by 2. Clear or confusing? Clear or confusing? Come on, guys.
It's clear.
Let's do one more example. 3 by 3. Of course, 3 by 3 is crazy by hand. For example, I propose you, and this is the double checking you don't need to do. Only compute the answer of that question is this. Okay, by the way, is the option B, no? B. Okay, let's do in 20. This was 22. 23 is similar. Let's keep that. 24, let's do at least one of the 3 by 3. Okay. Boom, that one. Okay, I propose you the time that we have doing 24. The problem is that no, it's no big deal, but it's too long. And 26. And this is using the software. Without software, crazy. So let's do in 24 and let's do in 26. Okay, I have here 26. And that's it for today. Okay, 24. Let's come back to algebra. Okay. Do you see? Okay, in 24, we have a square matrix. It's 2. Do you see or no? Let me know. -1, yeah. -1. We are doing 24. +1, -2. So there are no formula. If you want, I explain how, but there are no formula to compute 3 by 3. No. However, you can do using algebra, of course. -1. I copy right or copy wrong? I select this matrix, create matrix, N1. And you encast, you put invert. Invert matrix N1. And the answer is -1, -1, 2, -3, -2, 4, -1, -1, 1. And this is the option A. Got it? Do you follow me? If you want after, you can verify. See the multiplication for the matrix identity. Let's do it because it's no big deal. It's easy. You invert N1. Okay, of course, I have here. Outside the parenthesis multiplication by N1. The bound. Okay, the multiplication is always the identity matrix of the dimension 3, I3, capital I3. It's clear?
Yes.
Clear? Yes. Okay. Okay, let's move on to the last problem in the whiteboard. I want to explain anything. Okay, you. Boom. Boom. Okay, suppose. Let me try to understand this problem. This is another way to solve the system of equation. You create the matrix A, okay, the matrix in that case 1, 2, 3, 1, 1, 1, and 1, 0, -2. Okay. Entonces they are good guys because say que the inverse matrix of this, que the matrix formed by coefficients in front of the variable, is this. It's given. So A inverse is given is -2, 4, -1, 3, -5, 2, -1, because it's complicated, very, very complicated, do by hand. After we can verify that, okay? Just in case. And the formula is que the variable x, y, z is equal the inverse matrix multiplication by b. And who is b? B is the vector formed by the right-hand side number. In our example 4, -5, and 6. So actually, the only thing you should do is compute the inverse matrix multiplication the inverse matrix time the vector b in this order, inverse time b, and you get three numbers. Bam, bam, bam. And this number is x, y, and z. Okay? But let's do it in GeoGebra. Okay? Because it's too complicated by hand. Okay. Well, let me try. I delete that part. Yeah, I start. So the only thing I suppose you see, no? You see or no? 1, 2, 3. Do you see GeoGebra? Yes or no?
Which is
Yes.
1, 1, 1. And 1, 0. And -2. This is my matrix A. I need also the right hand side number, okay, 4, 5, and -6. Yes. Okay. I select the matrix A, I form the matrix A. Matrix A. Okay, I rename because I don't like this thing. I want capital A. Capital A matrix. Boom. Okay. Okay, super. Now B. It's doing B now. Select this, another matrix, but this matrix 3 by 1. No? Create matrix 3 by 1. And this is called B. Rename B. Boom. And you encast, you apply the formula. The formula is invert, 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 invert matrix, U matrix A, capital A of course, multiplication. Oh no. Well, okay, this is inverse matrix. Actually, I want to check it, -2, 4, -1, 3, -5, 2. Okay. Now the operation, the complete operation without, I press enter. I can change that. Invert again of the matrix N1, but capital A, but no press enter. No. I go outside the parenthesis, multiplication by B. By B. And press enter now. Boom. And the answer is -22, +25, and negative. And this is the final answer. So the interpretation is x is equal -22, y is equal +25, and z is equal negative. In the story. Okay, let me check it just in case. And the whiteboard. Okay. Okay. That's good. Okay, whiteboard now. Okay, here, over there. Okay. Okay. Let me. Okay, could you checking this number and the inverse matrix? It's exactly the same we compute in the GeoGebra. And GeoGebra, remember, I put invert. This is the language of the GeoGebra. Invert A. Multiplication B. And you get that. -22, +25, and negative. Therefore, x is equal -22, y is equal +25, and z is equal negative. Okay. End the story. We finish. Any question? Any question? You get the idea?
no question.
Do you want to do one more or no?
Yeah, zoom more.
Okay. Let's do it 27. In this moment, you are working with your own GeoGebra or no? Or you watching to me?
I have GeoGebra open.
Okay. This is was be good. So you try. Okay, so now what's the idea? The idea is you typing in GeoGebra that matrix A, que es different a little bit. 1, 2, 3. A little bit. 1, 1, 1. And negative 1, 1, 2. Okay, we are doing 27 question. And matrix B actually is a vector because the terminology when you have 3 by 3 is a matrix, but when you have 3 by 1, so when the one dimension is 1, it's a vector. It's a column vector. No? It's negative 9, negative 12, and negative 8. Okay. The thing we are doing is putting algebra. When you put in the spreadsheet that you create the matrix, you rename, you find the inverse matrix, multiplication by B, and you get a new column vector 3 by 1 with the solution case 11, negative 49, and 26. Come on, guys. Everyone have your own Jira open or no? Yes or no? No? Answer me. Yes, no, no, yes.
I just did it.
Okay. Try. It's easy. You type in the matrix A in the spreadsheet. You type in B in the spreadsheet. You create the matrix, change the name, rename, and apply the formula. A inverse times B. And you compute that. All right.
Yeah, mine's the same exact one as your answer.
Excellent. Now, who more do that? You are Mr. What's your name?
Rolando Izquierdo.
Rolando Izquierdo. Okay. Okay. Who more? Come on, female. Diana Marina. You're using Georgia right now, Diana Marina, or no? Diana Marina is sleeping now. John B. Rodolfo Perez. It's good to take attendance now. Anthony Irizarry. Gabriel Navarro.
Yeah, I'm
Yeah.
here. I'm doing it in GeoGebra.
Okay. Anthony Esposito. Okay, let me see. I am here. Anthony Irizarry, I am here. Micro Salavarria. Hey, take attendance.
I'm here, Professor.
And you are doing something or no? Or you waiting for the when you study by yourself? Huh? Answer me.
Wait, what? Repeat again, Professor. I didn't hear you.
The question is, the thing I'm doing in GeoGebra, you are doing in your own laptop or no?
I just take after you're done writing the program. I usually just take screenshots.
The answer is yes or no? No?
I guess yes.
Okay, honestly, you know, so you practice after, no, Professor? I practice after by myself, no?
Oh, that's what you mean. I was so confused. Oh yeah, I practice after myself. Every time I do the thing, I take time to practice.
Okay.
I was just like super confused at what you asked me. I'm sorry, Professor.
Sorry, my English is not clear, maybe.
Yeah, it was not clear, so I couldn't understand what you meant by the question.
A ver, Cariston, Desert, Claudia. Claudia, are you there? Wow. Matilde Moyo, she's fantastic.
Yes, I'm here.
Matilde, you practice GeoGebra or not yet?
Yes.
Okay, super. Okay, guys, entonces that's it for today. Remember, it's clear que the due date is this Friday. Both tests, written test, plus online test and homework. Remember, homework is optional, no? The homework is extra point. Student you want to get 10 points, well, you are doing the homework. You need doing the homework when the score greater than 80. See, the score is less than 80, no extra point. Clear?
Yes.
Have a nice
Professor.
day.
Clear.
I get,
Yes, well.
bye-bye.
Professor,
have a
real
good
quick.
night.
Okay.